Okay, here is the derivation for the maximum work. So there are two steps, the first one being to set up the equation in terms of these two expressions, the Laplacius inequality and the first law. And the second step is to rearrange to solve for work. So in the first step, the Laplacius inequality, which is true for irreversible spontaneous processes, is equal to ds is greater than or equal to dq over t. And then we have the first law, which is du is equal to dq plus dw. So we actually want to rearrange this to isolate dq. So t ds is greater than or equal to dq. Then here we also solve for dq. So du minus dw. So now we can substitute this expression into our inequality with TDS greater than or equal to du minus dw. So there's our equation. Now we have to rearrange to solve for dw. So here we can see that TDS minus du is greater than or equal to negative dw. And then multiplying everything by -1 flips the inequality. So du minus TDS is less than or equal to dw, or dw is greater than or equal to du minus TDS. So this is our inequality. Now the question is, at what point is work maximized? So the standard convention is that when the system does work onto the surroundings, this is a negative W. So if you want to increase the work done by the system, then we want this to be more negative. So we want work to be more negative. Right, well, not like in magnitude, we just want it to be more negative. So looking back at this expression, we have two options here. We can either be greater than or equal to. So in which case would work be more negative? When it's greater than du minus TDS, or if it's equal to du minus TDS? Well, obviously the answer is equal to, because if you're greater than, then that just means you're more positive or less negative. So essentially, dw maximum is equal to du minus TDS. And there's our expression. Final note, du minus TDS is actually equal to the Helmholtz free energy, which is basically A is equal to U minus TS, and evaluated over an infinitesimal process, dA is equal to du minus TDS. So here we can substitute this for dA, with our final expression being dW max equal to dA. There you go.